On December 15, 1977, Voyager 1 passed its twin Voyager 2. Since then, Voyager 1 has been a key tool in exploring the mysteries of the universe. The spacecraft began taking images of Jupiter in 1978, when it was about 265 million kilometers from Earth. In January 1979, Voyager 1 took 3,750 images of Jupiter in 100 hours. These images were later combined into a time-lapse movie showing 10 revolutions of the gas giant. By February, Voyager 1 had already passed through Jupiter's complex system of moons, discovering faint rings and 2 new moons. These discoveries prompted NASA to modify Voyager 1's orbit around Saturn so that it could avoid Saturn's largest moon, Titan. Meanwhile, Voyager 2 discovered 4 more moons around Saturn: Mimas, Enceladus, and Dione. After these planetary encounters, NASA ended the Voyager planetary mission, sending both Voyagers beyond our solar system at a rate of 325 million meters per year. The Voyager interstellar exploration officially began in January 1990. At this point, Voyager 1 was nearly 6 billion kilometers from the Sun. On February 14, 1990, he took the famous family portrait of the solar system, a series of 60 images showing the Sun and most of the planets, bringing the total number of Voyager 1 images to 670. Unfortunately, Mercury and Mars were not included in the portraits due to technical limitations. Voyager's cameras were eventually turned off to conserve power and memory for interstellar travel. In 1998, Voyager 1 surpassed Pioneer 10 as the most distant human-made object in space. After years of exploring uncharted territory, on August 25, 2012, it officially entered interstellar space, a milestone NASA announced in 2013. By November 2008, both Voyager probes had crossed the solar system, marking the edge of our solar system. Today, Voyager 1 is about 145 billion miles from Earth, still transmitting data from this uncharted frontier. Recently, scientists have been concerned about unusual signals from Voyager 1. Despite its 45 years of operation, these irregular signals suggest that the spacecraft may not be sure of its exact location. Moreover, Voyager 1 was designed to go into safe mode or send warnings if something went wrong, but its radio transmissions remain active despite the strange data. Voyager 2, on the other hand, continues to operate normally, receiving and executing commands from Earth. As a backup, both spacecraft carry 12-inch gold-plated discs containing sounds and images of Earth in case they are discovered by extraterrestrial beings. The discs contain 35 sounds of Earth, 115 images of life, an hour and a half of Western music, and the wishes of former President Jimmy Carter and former UN Secretary-General Kurt Waldheim. These recordings are in 55 languages, making it more likely that extraterrestrial beings will be able to decipher the contents. Despite some speculation, the idea that Voyager was piloted by aliens has been rejected. Voyager's attitude and orientation control systems are still essential for transmitting accurate data back to Earth, and scientists are confident the spacecraft is functioning, even if the readings are confusing. Susan Dodd, Voyager 1's mission manager, confirmed that the security system was not activated, deepening the mystery. The spacecraft is over 45 years old, far beyond its original mission lifespan. Because Voyager 1 is 145 billion miles from Earth, engineering teams are having a hard time troubleshooting the problem. It takes about 21 hours to send a Voyager command from such a great distance, meaning a delay of almost 2 days for each exchange. This delay makes troubleshooting even more difficult, as each command must be thoroughly tested on Earth before being sent out to resolve issues without causing new problems. Engineers are working with technology from the 1970s, making troubleshooting difficult, especially since the spacecraft must withstand the harsh environment of space, where micrometeorites, high radiation, and extreme temperatures can wear out components. The team decided to address these issues by running simulations and examining the spacecraft's backup systems onboard Voyager 1 to improve reliability. Susan Dodd is confident that the current issues, particularly those related to the attitude control system, can be resolved. NASA doesn't yet know how long Voyager 1 will be collecting and transmitting data, but the engineering team remains focused on finding a solution. Voyager 1, the most distant spacecraft ever launched, is exploring uncharted territory nearly 50 years after leaving Earth. Scientists are puzzled by the strange signals it returns from interstellar space, but this amazing spacecraft continues its journey, revealing secrets of the universe beyond our solar system. Voyager 1's journey represents one of humanity's most ambitious and sustained missions to explore the universe beyond our solar system. From the day it launched to its current location, billions of miles away, Voyager 1 has transmitted invaluable data about our cosmic neighbor. One of its most iconic contributions was the photograph, Pale Blue Dot, taken in 1990 at the request of Carl Sagan. In this image, Earth appears as a tiny dot in the vastness of space, a perspective that has redefined our understanding of our place in the universe. This one image has inspired generations to think of Earth as a fragile home floating in infinity. As Voyager 1 travels through interstellar space, it continues to measure cosmic rays, the density of interstellar matter, and magnetic fields. This data has deepened our understanding of the space environment beyond the influence of our sun. The mission is gradually helping scientists to reveal the composition and structure of interstellar space, a place where no human-made object has ever set foot. However, as Voyager 1 and its twin Voyager 2 travel farther, NASA has begun to turn off some of their equipment to extend their lifespans due to their limited energy reserves. This conservation strategy is necessary because each spacecraft is powered by a radioisotope thermoelectric generator that produces less power each year. Nevertheless, the team hopes to extend the lifespan of both spacecraft through creative solutions and careful management, keeping them operational well into the 2030s. Voyager carries a message from humanity on a gold record containing music, sounds, and images that represent life on Earth. If the spacecraft encounters intelligent extraterrestrial life, the recordings are intended as a form of first contact, revealing who we are as a species. Now billions of miles away, Voyager's messages remind us of our desire to communicate and connect, even across vast, empty distances. Despite these challenges, the Voyager team continues to do its best to reveal what lies beyond our solar system. They recognize the unprecedented nature of this mission, operating a spacecraft and technology far beyond their intended service life in an environment that is more hostile than expected. As Voyager 1 moves away from Earth, its journey reflects the human spirit of exploration, demonstrating human curiosity and ingenuity. Every packet of data Voyager 1 sends contributes to a profound legacy that will be remembered as one of the most daring steps in space exploration. The journey will continue, bringing us closer to answers about what lies beyond our familiar solar system, and its signal will resonate for as long as possible. It will be a constant message to the universe that we are here and want to know what lies beyond.